मापी है जो कि सूर्य के प्रेक्षण के लिए प्रयोग किया जाएगा। इसमें HE-L1OX हाई एनर्जी L1 ऑर्बिटिंग एक्सरे स्पेक्ट्रोमीटर है जो कि हार्ड एक्सरे वर्णक्रम मापी है। इसकी अभिकल्पना सोलर फ्लेयर के अध्ययन के लिए की गई है। यथास्थिति निर्धार में आदित्य सोलर विंड पार्टिकल एक्सपेरिमेंट, इसका उद्देश्य है सोलर पवन, सौर पवन में भारी आयंस, प्रोटॉन्स और अल्फा पार्टिकल का विश्लेषण करना। अगला है प्लाज्मा एनालाइजर पैकेज फॉर आदित्य। यह भी सौर पवन में उपस्थित कणों में इलेक्ट्रॉन और भारी आयंस की दिशा के साथ विश्लेषण करने के लिए इसे बनाया गया है। एडवांस ट्राइएक्सियल हाई रेजोल्यूशन डिजिटल मैग्नेटोमीटर, इसे त्रिअक्षीय चुंबकीय क्षेत्र के यथास्थिति मापन करने के लिए बनाया गया है और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में।
Vehicle performance normal.
यान पूरी तरह सामान्य, सभी तंत्र सामान्य रूप से कार्य कर रहे हैं और यान अपनी उद्दिष्ट कक्षा की ओर बढ़ रहा है। आदित्य L1 के निर्धार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। विजुअल एमिशन लाइन क्रोनोग्राफ VLC इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स बेंगलुरु द्वारा तैयार किया गया है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप सूट इंटर यूनिवर्सिटी सेंटर फॉर एस्ट्रोनॉमी एंड एस्ट्रोफिजिक्स पुणे द्वारा निर्मित है। सोलेक्स और एलियोस दोनों ही URO सैटेलाइट सेंटर बेंगलुरु द्वारा निर्मित किए गए हैं। ASPX और PAPA स्पेस फिजिक्स लेबोरेटरी VSSC तिरुवनंतपुरम द्वारा निर्मित किए गए हैं। और अंत में मैग्नेटोमीटर लेबोरेटरी फॉर इलेक्ट्रो ऑप्टिक्स सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी चर्चा में, जहां वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे और फिर इस चर्चा के बाद हम वापस आएंगे लाइव इवेंट्स में।
As we are in the low visibility region of the flight path, we take you to the discussion room where the key personnel connected with the Aditya L1 will enlighten more on the payloads and details. Over to discussion room.
Welcome viewers. After India has made history with the Chandrayaan 3 moon launch, it has now set its eyes on the sun. These scientific breakthroughs back to back are like feathers on our country's hats. In fact, these celestial bodies are very important and are considered as sacred bodies in multiple global religions. The sun is the central body of our solar system. The world revolves around it, and it is a source of energy for all planets, including the Earth. Today, I'm joined by all the scientists who have played behind the scenes to make this project a grand success. And I'm Srinidhi, reaching out to you from the Satish Dhawan Space Center, Sriharikota. And today we'll be discussing about the impact and the benefits of the Aditya L1 space mission. So today we are joined by Dr. Anil Bharadwaj, Director of PRL, Professor Annapurni Subramanian, Director of Indian Institute of Astrophysics, Dr. Sankara Subramanian, Principal Scientist of Aditya L1 mission, Dr. Durgesh Tripathi, PI of SUIT, Dr. Dipankar Banerjee, Director of IRIS, Nainital, Dr. Satish Tampi, PI of PAPA, and Dr. Vipin K. Yadav, PI of Magnetometer, joining us today for a 25-minute fireside chat on the sidelines of Aditya L1 launch. To start with the principal scientist and PI of SOLEX, Dr. Sankara Subramaniam, why is Aditya L1 mission so important and what are the objectives of this mission?
Thanks a lot. First of all, let me thank ISRO as well as the Government of India for providing a great opportunity for the solar and heliophysics community of the country. Both solar, heliophysics as well as astronomy thrives on data. More the data you have, we get more understanding about the system. And Sun is our own star, our dearmost star, so understanding them is much more important for our everyday life. So this mission, Aditya, when it was conceived initially, with a support from our Professor U.R. Rao, along with Dr. Srikumar and Professor G. Srinivasan, we made sure that we will have a unique data set which is not available from any other missions internationally. So the 7 payloads, what was conceived for this particular mission, will provide that unique set of data which is currently not available from any other missions, which will provide us new insight into the solar and heliophysics community in India, and provides some important aspects like the initiation of the coronal mass ejections, the speed at which it gets initiated, and some wave bands which are very important for the Earth ionospheric connections, like near ultraviolet band, and the high energy particles, which is high energy radiations as well as particles which is coming from the solar flares and coronal mass ejections. So these are the informations which would be available from this particular mission, which will allow us to understand the sun, its dynamics, as well as the inner heliosphere, which is an important element for the current day technology as well as the space weather aspects of it.
Thank you so much for your remarks, sir. So now we'll move on to Dr. Anil Bharadwaj. So the sun is a very important energy source of life. Having understood that, it creates a trouble when it's angry. How does Aditya L-1 helps us through the mission?
Thank you and good morning, viewers. First of all, let me tell you that Aditya L-1 is a multi-wavelength, multi-instrument and multi-directional mission. Multi-wavelength because it works in X-rays, UV and visible. Multi-instrument because there are 7 experiments on board. And multi-directional because it looks not only in the sun direction but also around it. Now when the sun becomes angry, there are 2 types of process which happens. One is solar flares, that means electromagnetic radiation, which reaches the earth in 8 minutes. But along with that, there is a mass which is also ejected out in form of plasma, and that can take about 2 to 4 days to reach the earth. What we are looking for from the Aditya L-1 mission is to see the impact of solar flares as well as coronal mass ejections as they come to the earth. We have instruments which look at not only in the sun direction but also in other directions, for example perpendicular to ecliptic or in the earth directions. The impact is that we need to see when the sun becomes quite angry, what are the ways in which it is affecting the planet Earth, and L1 point being at point L1, which is just 1% away from the Earth, it is able to provide us a lot of new informations of the plasma and the electromagnetic radiations which is reaching the planet Earth.
Thank you so much, sir. So now we'll move on to Dr. Annapurni Subramaniam. So the science behind this mission is very unique. So what's the impact of this on the Earth and also on the heliosphere?
Yeah, so thank you for having me on this show. To put the thing in context, I'm the director of Indian Institute of Astrophysics, and we have delivered one of the major payloads on this mission. This is the visible emission line coronagraph. So if you actually look at the words used in it, it is visible because it is seeing the sun and the visible wavelength. Emission line, so what is it detecting? It is the emission line of certain elements. Because the corona is hot, the emission which you get is in the terms of, it's not absorbing the light which is coming from the sun, but it's already hot, so it is coming down by emitting lines. So we are tracking these lines using what? A coronagraph. Now what's a coronagraph? This instrument makes a total solar eclipse all the time within the instrument. So you are looking at the sun all the time, 24/7, using this mission. And this instrument looks at the sun as though it is always in total solar eclipse. Now, why you want to have the eclipse all the time? Because you want to see the corona. Why corona? Because when sun burps, when sun is angry, the corona is what it takes the matter away. Now, what is unique about this instrument? This is going to see the corona as close as possible from the disk of the sun. Now, what is so challenging about it? It is because the sun's corona is 1,000,000 times fainter than the disk of the sun. So you have to not see the disk of the sun, but see only the corona. So this instrument is very difficult to make, challenging, but it is made. Now it's going to the orbit. Now what we planning to study using this instrument is the corona, its dynamics. Through this emission line, you can actually measure the velocity by simple physics called Doppler effect. So you can measure the velocity, you can measure how much matter is moving, and eventually how that matter will come to the Earth and the heliosphere. So it's overall this instrument, along with the others, of course, the other PI will also be explaining about it. So these holistically will give you a lot of information regarding not only the sun, but also the heliosphere. Thank you.
That was very interesting, Doctor. Thank you very much. And now we'll move on to Durgesh Tripathi, Dr. Durgesh Tripathi. You are the PI of the for the payload suit. How is that different from other telescopes like Hubble or James Webb? And what are you going to investigate using this?
Good afternoon. My voice is going to mumble because I'm still in the awe of the launch, and one of the payload is gone there. So essentially, JWST, which is James Webb Telescope, and the Hubble Telescope, they are going to look at the universe, different objects, galaxies, star formation, and other objects you see in the universe. Whereas when we talk about Aditya L-1, it is going to look at one particular object, which is our sun. And it's also kept on the other side of the Sun-Earth line at the L1 point, whereas the James Webb Telescope went on the other side of the Earth, which is at the L2 point. Now, the scientific difference, of course, they also observe in ultraviolet, but Aditya, as Professor Anil Bharadwaj and also Professor Anna Purnisubramanian alluded to, these are multi-wavelength satellite, and they will be observing all across the electromagnetic spectrum. In particular, SUIT is going to be looking at the ultraviolet radiation in 2000 to 4000 angstrom, if that matters to you, emits from the lower and the middle atmosphere of the sun. And what we want to look at that how in general the sun's atmosphere is coupled by looking at the observations at various height, and how actually this radiation is coming and getting absorbed in the Earth atmosphere, and what kind of effect it can have in the chemistry of ozone and oxygen, for example, and also these explosions which are happening, how much radiation they are creating, and how much effect it might have.
Thank you very much, sir. And now we move on to Dr. Satish Thampi. You are connected with the payload PAPA. Already the plasma particles on the moon are analyzed. How do you analyze plasma particles in the sun? And what is the importance of solar winds, and how does it impact?
Thank you for giving opportunity to come into this role. As my colleagues, they mentioned actually about the sun. Today we have the auspicious day where actually we are going to our own star, that is the sun. Just I want to tell to the viewers that actually the sun, which is our hero basically in the solar system. If you look into the mass of the solar system, 99% of the mass of the solar system is occupied with sun. And also this sun is plasma. Now when we are talking about the heliosphere, actually with this all our planets are engulfed in that thing. You know, we have been studying in decades, maybe in centuries, we have been studying about the sun. But what we are lacking actually a comprehensive approach, because sun is giving its energy mainly in three forms. The first one is the radiation, actually my colleagues already talked about, which we can do remotely from our ground. But the plasma, basically we are talking about the solar wind, what we call the space plasma, as well as the magnetic field. This can be only studied by in situ. If we study all this radiation, particles and field, then only we will get a full comprehensive understanding of the sun. Now, we are getting the first space-based observatory from the Indian soil, and we are making this opportunity. And of course, I am thankful to ISRO and all my colleagues and my teammates from VSSC and all my scientific colleagues here. This is the opportunity we got actually. We are trying to understand actually all the three things: radiation, particles, and field. Already they mentioned about the radiation. Now, Dr. Bivin will be talking about field. Just I want to emphasize on the particles. That's why we named it as PAPA. PAPA means Plasma Analyzer Package for Aditya. This is developed by Space Physics Laboratory in support of Vikram Sarabhai Space Center. And now this instrument has two components. If you look at the solar wind, basically it comprises of 95% protons, then alpha particles roughly around 4 to 5%, then equal number of electrons also. So our PAPA is a comprehensive package measuring both ions and the electrons. Now these electrons, like already our colleagues they mentioned actually the major transition events like coronal mass ejection. That's huge mass which is coming out of sun. Basically it's a plasma. Basically, when we are talking about solar wind, basically nothing but it's the extension of the corona only. That must have. Now, these particles actually, they only actually modulate the energy and momentum of the planetary atmospheres. See, we when the sun is quiet, like it is not aggressive, sun is what we are getting the ambient solar wind. So if you look into that thing, actually, that one actually gives what we call it about the interactions, what we call the normal routine phenomenon which is happening on there. But when there is sun is angry, so it gives like CME, CA, or these sort of events are happening. That is really going to affect our planets. That's what we call the space weather. Now, our intention is to understand, first of all, actually, what these effects, basically the solar wind, in the ambient condition, as well as during this transition universe, how this solar wind behaves, and also how this coronal mass ejections, which is passing through different planets, how actually, what are the different things, like what we call about the microphysics, macrophysics, and the mesophysics of that things that we want to understand. So one thing is actually it's a physics subjective to understand, because we are getting an ideal point, Lagrangian point, which is in the sun-earth plane, and we will be seeing the events exactly there. Second thing is actually we can definitely monitor the parameters. Like particularly Papa will measure electrons and ions. We will be getting energy, direction, and angular information. Mass information. So if we know these things related to electrons, the electrons we don't want the mass, but for the ions we are getting the mass information. Coupling all this information, actually what we can do is we can derive the plasma moments. That will be definitely going to the modeling part, actually dynamics part, and that will definitely going to tell about the effect of the space weather effects.
Yes.
So in due course, actually, with the L-1, in addition to other L5 missions, we will be able to tell. This is the importance of the plasma missions.
Yes.
That actually, as you mentioned, actually earlier with the lunar mission we achieved, we tried to understand that thing. Really, it changed this plasma studies, changed the perspective of the moon. Now, Aditya will give more detail.
Yes.
Thank you.
Thank you, sir. Thank you so much for that, sir. And now we move on to Dr. Dipankar Banerjee. So, you manage the beautiful solar observatory at Nainital.